Okay, this one. Question 5 part 2. Okay, 5 part 2. Here, the mistake you made over here is this one. There's a plus 5. It should be a square root 5.
Oh,
Easy?
yeah.
You missed out a square root. Okay, that's all. Otherwise, I'm sure you know how to do it. I showed you the working over here. Next. Over here, okay, there is a better way to do this instead of manually expanding, but good that you did it. Did you realize that this power 1/3, you can just replace it with a letter A, and this y power 1/3 is a letter B? Then in that case, do you notice that 1/3 go to 2/3? Isn't that just the square? So this is really just A square. Then y power 2/3 is really just B square. Then this fellow over here in the middle is minus AB.
Oh, what the hell? Okay.
Then what is this? What do you see? Does this look familiar?
Yeah.
Yeah, A cube plus B cube formula. Okay. Then you can rewrite it as A is x power 1/3 power 3, y power 1/3 power 3. What happens when you have 1/3 and 3? Multiply, you get 1. So just x power 1, likewise y power 1. That's the answer. X plus y. Okay? Yeah. Okay, next one. Okay, just a note. I'm a bit scared. When I see this Q, right, try to move it up a little bit. Because your Q is at the bottom. You should try to move it to a bit more upwards. But you understand now, it's at the numerator. Okay? Right, the difference between these three. The Q at the bottom will mean a different thing. Draw a line. So just try to move it. Your Q here, you don't screen mode. Okay, you don't move it. You don't write it so bottom. You move it slightly to the middle, or all the way to the top.
Okay.
Okay. Can yeah. Let me just change back to presentation mode. Okay, then this one, how to continue over here. 4.8 divided by 3 multiplied by 5n power 2 equals to a times b 5 power bn. So what you need to realize is the pattern. There is a number multiplied by a base 5 raised to the power. So you need to follow the same pattern on the left-hand side. So what you realize is that 4.8 over 3 is really just a number, just like your a. So we can simplify that. 4.8 divided by 3, it's 1.6. Oh, before that, do you know that 4.8 over 3 times 5n power 2 you can rewrite as 4.8 over 3 multiplied by 1 over 5 power 2n?
Yeah.
Can Okay, good. Then 4.8 divided by 3, you get a 1.6. 1 over, you just have to change it to a negative power. Is this part okay?
Yeah.
Can So now you got -2, and then you can just compare blue color with blue color, yellow color with yellow color. Then you get your answer. Can you see the pattern? Can Okay, good. And that's all. Yeah, so just one more step only. Another problem. Nothing wrong. Yeah, here is the same trick. It's the same trick. You just need to compare. Okay. What we can do is the right hand side we can modify a bit. So 2 power b times x power a times b. The b bring in. Right. Then you can compare 5 with b, 11 over 2 with ab. You already solve for b. B is 5. Then you can substitute in. So you get 11 over 2 equals a times 5. Solve for a. Can? Is it clear?
Hello.
Can okay, good. I can hear you now. Is it clear?
There was like lag and stuff.
Okay. Mic test. What is 1 plus 1?
2.
Okay. Well, the lag is around 5 seconds. Okay, I'll just continue. Good. Can I move on?
Wait. Can you say what you say again for this?
Can. So on the right hand side, we got bracket 2x power a to the power of b. So we just need to bring the b in. So what happens on the right hand side? It simplifies into this 2 power b times x to the power of a times b. Is this part okay? The right hand side?
Oh, okay, yeah.
Then now the left hand side, you already have it as 2 power something times x power something. Right hand side, you also have it as 2 power something times x power something. They are the same format. So you can just compare the powers. 5 with b, blue color. and 11 over 2 equals to a times b. We already solved for b equals to 5, so we can substitute in the b. What we will get is 11 over 2 equals to a multiplied by 5 instead of b. I replace the b with 5. This part okay?
Yeah.
Then you can solve for a already. Divide by 5 over. So you get 11 over, oh, sorry. Sorry. Here should be a 10. Sorry, help me to change that. Should be a 10. Sorry. I don't know how to divide. 2 times 5 is 10. Yeah. 11 over 10, sorry. 11 over 10, not 20. Can?
Okay.
And okay, good. Next. Same thing over here. The answer is really just x for this one. The challenge is how do you show that this is equal to x? And do you know it's x in the first place? So let's take a look. You do a similar trick. We're gonna let the smallest power be x. So here you got 6 root of x. Here you got cube root of x. Here you got 7 over 6 to the power as the power of x. And here you got x power 1. So which is the smallest power?
X power 3.
No.
Wait. I mean, x.
This should be 1 over 3. Here will be 1 over 6. Here will be 7 over 6. Here will be 1. Maybe I write it down. 1 over 6 power. This one is 7 over 6. This one is 1. That one is 1/3. Which is the smallest?
1/6.
1/6, exactly. So that's why I let a equals to x power 1/6. Okay, or 6 root of x. So that means that this expression here can be rewritten as a minus 1. Then x power 7 over 6 is really just a to the power of 7. Then x power 1 is just, how do you go from 1 over 6 to 1? You just have to raise it to the power of 6. Right? 6 times 1 over 6 gives you 1.
Okay.
So it's a power 6. Then the denominator, how do you go from 1/6 to 1/3? How do you go from x power 1/6 to x power 1/3? You just have to square it. So it's a squared. Then minus 1. So far, okay, this part?
Yeah.
Okay, then now here's the challenge. You have to be a bit creative. You need to realize that a square minus 1 here is actually just a square minus 1 square. Then you can factorize as a minus 1 times a plus 1. Then on the numerator, you realize the a minus 1 can cancel off. You're left with a. Okay, maybe I shouldn't even have bothered to factor out the a here. Here, what I did was a power 7 plus a power 6. Then I factor out a and then I leave it as a power 6 plus 1. Actually, that was a bit extra. I didn't need to do that. I should have went a step further and factor out a power 6 here. Okay, so what I did is I factor out and then I expand again. And then finally, I factor out a power 6. Can you see that? So this part is a power 6 bracket a plus 1.
Okay.
Can now? Then what happens to the denominator? It has a plus 1. Right? Just now we cancel off a minus 1. We are left with a plus 1. Left with a plus 1. But now numerator and denominator both got a plus 1. They can cancel off. So you're left with a power 6. Can you see that?
Yeah.
What's a power 6?
Just x.
Yes, exactly. You raise to the power of 6 of the 6th root. You cancel each other off, you're left with just an x. Okay?
Okay.
Yeah, so the trick here is to do substitution. Substitute with the smallest power. Maybe I should write this down. Here is the smallest power. Among all the powers of x, there's a 1/6, 1/3, 7, 6, and power 1. You let a be equals to x to the power of the smallest power. Okay, so that everything will now become whole numbers, like 7, 6, 2, easier to think. Humans, I feel, are bad at fractions and negative numbers. Okay, we don't work well with negative numbers and fractions. So it's better to convert into a whole number. Okay?
Okay.
Okay, next one. 14. The answer is negative a over b power n. Okay. How to show that? Let me show you. So you have to be clever lah, no choice this one. Factorization is difficult in the sense that there's no, you need to guess and check. So here, what you realize is that a power 2n, a power n. There's an a power n you can factor out, right? So after you take out a power n, what happens? You're left with a power n plus 1. How do you check that it's correct? You multiply again. Same base, different power, you multiply, you add the power. N times n plus 1. Does it give you 2n plus 1?
Yeah.
Yeah, so it's correct. I factor x correctly. Then let's check a power n times negative b power n minus 1. Does it give me my negative a power n times b power n minus 1? Minus?
Yeah.
Yes, okay. Then likewise, you can do the same with the denominator. Okay, so you're left with b power n minus 1 minus a power n plus 1. But you realize that numerator and denominator at this stage, doesn't it look the same? Almost.
Okay.
What is it off by? Off by
-1.
Yes, exactly. So that's what I did over here. I factor out a negative sign. So now I can essentially swap their orders. The plus sign here become a minus, the minus here become a plus. Then I just rewrite it neatly, plus at the left, minus on the right, so that it looks exactly the same as the numerator factor. Then I can cancel off. Does it make sense? The cancelling?
Yeah.
Can Then you're left with a power n over negative b power n. Rewrite it neatly as this guy. Then that's your answer. Okay? Is it okay?
Yeah.
Can Okay, good. Next. 15, okay. 16, not okay. This one have to be clever again. So what did they tell you? They told you to express your answer in the format of some constant divided by the square root of a f of x. Do you know what they mean by this?
No.
Okay, what they mean here is that a is just a number, no square roots, no nothing, just number, no square root, no square root, no variables as well, no x. Just a number, just purely a number a. Then here, square root of f of x means that you need to, your final answer, you must display a square root something. Okay, I'll just show you the final answer. Oh, sorry. Actually, a. Did they say a? Let me just double check the question. Where did I put the question paper? Sorry, let me find the question first. This is question 16. Oh, sorry, I read the question wrongly. It's not A, they said X. Whoops, X. Yeah, so X just means just put a single X. Okay, the final answer is this. X divided by a square root of what? Square root of x power 4 plus 1. Then x power 4 plus 1 is your f of x. You remember function notation? F of x. Yeah, so that's just the question's way of telling you you need a function, something in terms of x. Can be anything, underneath the square root. Okay, this is the final answer. Let's see how we can get that. So we begin with the original question. You notice that there's the square root on the numerator, correct? But the final answer, there's no square root. Then how? That means we need to do something about the square root. Here, the denominator got square root, so it's okay. So that's actually quite good because the final answer, we also need a square root. So let's think about it. Here, it's not an equation, so you cannot go and square both sides of the equation or anything. You cannot go and square. Squaring it will change the expression. So squaring that, although it may help us to get rid of this square root, right? It is not an equation, so we actually cannot do it. Is this part okay? Is this part clear?
Okay.
Yeah, all we can do is to multiply them together, which is what you did here. Okay, that's good. But we can go a bit further. Here, x power 4 plus x squared. Do you notice there's a common factor of x squared? You can take out. Yes? Okay, then what is so special about rewriting as a factor form? X squared times x squared plus 1. It means that now we can split it up. Square root a times square root b. If you recall, square root ab is equal to square root a times square root b. This applies not just to numbers, like 18 can split as 2 and 9. It doesn't just apply to numbers, it also applies to algebra. Here you got x squared multiplied by x squared plus 1. You can split it out as square root x squared plus 1. Is that okay?
Okay.
Then what I do is I swap the order. I square root x squared plus 1, then I write it on the left, and the square root x squared I write it on the right. So over here, square root the x squared, what happens?
X.
It becomes an x. Technically, it should be absolute value of x. Sorry. This is something to do with the. Hey, you didn't take H2 max, right?
No.
Okay, then
Like-
you.
Like I was there for a bit, but like not really. Yeah.
What was your first topic? Do you learn functions already? Domain and range.
I learned like because they know I never take AMS, so they had like extra class for me
Crash
or
course.
something. Huh?
Crash course. Yeah.
Yeah, they had like extra class for me or something. Yeah, but I didn't really get far with it, so I don't know.
Okay. Then the actual lecture itself, H2 one. Do you attend any?
Yeah,
You can remember.
they did. What did they do? I forget what they do. They sequence and series, I think.
Okay.
But I forget already completely. Like
Okay.
I didn't know what was going on because it's like yeah.
Data. Okay, understand.
Like I didn't take AMS. Then like a lot of it is like stuff I never see before. Then
Yeah, I can imagine that. That's quite difficult.
yeah,
Like
then
there's a huge gap.
yeah, no. Then that's why like my parents were like, okay, never mind. Just like yeah.
No, drop it out. Okay, can. Don't worry. So basically, over here, square root of x squared. Let me ask you: when you square a number, is it positive or negative,
When you square a number.
or is it zero? Oh, it can be zero if x is equal to zero. Zero square is 0 times 0, which is 0. But let's say it's let's say it's x is not 0, then you square it. What happens? Can it be negative?
I mean, I would think so.
When you square a number, think about it. There are only three types of numbers. Only three types of numbers. A negative number. So let's say x times x. That's x squared. Means it's either negative times negative, or 0 times 0, or positive times positive. Right? They have to be the same on the left and right because they are x times x. That's what x squared means. Then I'm saying that there's three types because there's only negative, 0, or positive. Agree so far?
Okay.
Then 0 times 0, I told you already, is 0. How about negative times negative? What do you get?
Positive.
How about positive times positive? What do you get?
Positive.
So in all three cases, look on the right hand side. This is x squared. Do you see negative?
X squared must be positive.
Exactly, it must be positive. Then when we take the square root, yes, it will cancel off. But in addition, original x, right, over here, it could have been a negative. But once we take the square root of x squared, and we know that x squared is positive, you take the square root of a positive number, would you expect it to be negative or positive?
Say again.
Sorry, that was a bit fast. X squared is positive or 0 already. That's what's underneath the square root.
Yeah.
Then now we take the square root. Square root. When you square root a positive or 0, do you expect it to be? What sign do you expect it to be? Plus or minus?
Plus.
Exactly. If it's positive, you take the square root, it should still stay as positive. This is what we call the principal root. Principal root. Only the minus only appears when we solve equation. Then we need to put a plus minus in front. But here it's just principal root. By definition, it means positive. So if we need positive, right? So if I just put down x, I never put modulus. You're saying that we know that after going through this logic of all three cases, we are expecting our x to always be positive once we take square root. Agree so far? Square root x squared should be positive or 0. Okay, 0 is a boring case. Let's just ignore it. Focus on the positive. But if I just put down an x, is there a possibility that the x is negative? The x itself, I'm not x squared. Is there a possibility that the x itself is negative?
Say.
Is there a chance that the x here is negative? Can, right?
Yeah.
Because over here, negative times negative. So we don't want that. How can we prevent that? We need to introduce something called the absolute value. Sorry, I didn't teach you this topic. Just I should have taught it earlier a bit, but now I'm introducing it now. Absolute value. Absolute value. Do you know where is it on your scientific calculator?
Or is it the ABS?
Correct. ABS. 2 vertical lines. So you just try it with a experiment. ABS, and then inside the square box you put in -2.
Okay, I
Put in
get
any
two.
negative numbers. You get 5. Let's say -5, you get 5. Sorry.
Yeah,
You put 0, you get 0. You put +5, you get +5. What do you realize?
it just turns it into positive.
Exactly. That's all by definition. Absolute value just turns things from negative into positive. Okay, so that's why we need to, technically, we should put down a absolute value sign. But absolute value sign a bit complicated to deal with. So I am going to assume, I'm going to, help me to edit the question. Help me to additionally assume that x is strictly more than or, is more than or equals to 0. I cannot say strictly. Okay, more than or equals to 0.
Okay.
Really, in fact, here you got x power 8 minus 1. X should be more than 1 already. Yeah, but never mind. Just write this down. More than or equals to 0. In that case, we don't have to worry about putting modulus anymore because x is guaranteed to be positive. You'll need to know this eventually when you're doing integration. So just keep that in mind. Keep this in mind that square root of x squared is by definition equal to the absolute value of x. Okay?
Okay.
Yeah. You square a number and then you take the square root. You will convert the x into a positive number. Okay. Anyways, moving on. Yes, we get an x. So where were we? We factor out this x squared from the x power 4 plus 1. X power 4 plus x squared. Then we split it up as square root x squared plus 1. Square root x squared plus 1 multiplied by square root x squared. This guy changed to an x. So this is just an x. But how about the right-hand side? What do you notice? X squared minus 1 times x squared plus 1. Isn't that just a minus b times a plus b? You see that?
Yeah.
Then 2 square roots, you can combine them together. So it's just a single square root. You multiply a minus b times a plus b. You get a squared minus b squared, which is x power 4 minus 1. Is this okay?
Yeah, okay.
Okay, clear so far? Okay, then now we're going to take a look at the denominator. X power 8 minus 1, x power 8 minus 1, x power 8 minus 1. So far, I did nothing. Now I'm going to do something. Look at my blue handwriting here. X power 8 minus 1. Do you realize that it's really just x power 4 bracket square minus 1 square?
Uh-huh.
4 times 2 is 8. So a square minus b square is? A plus b, a minus b.
Yeah.
Correct or not? So I just rewrite it neatly. X power 8 minus 1 is equal to bracket x4 plus 1, x power 4 plus 1, multiplied by x power 4 minus 1. This part, okay? Then, what do you realize? Over here, you got square root something divided by square root something. Isn't that just the same as square root of numerator divided by denominator? Square root a over b is square root a over square root b. So that's what I do here. I split it up. I combine it, sorry. At first it was split up. Now I combine it into x power 4 minus 1 over x power 8 minus 1. Then the times x, I just put it on the left side. I swap their order. So I end up with this one. This part, okay?
Okay.
Okay, then now, why did I have to factorize it like this? It's because now I can make x power 4 minus 1 divided by x power 8 minus 1 into 1 over x power 4 plus 1. From this equation, I can go into this one, which is the same as that one. Then I can replace it with this one. Does that make sense? Okay, let's slow it down a little bit. How do I get x power 4 minus 1 divided by x power 8 minus 1 into 1 over x power 4 plus 1? I start off with, correct. I start off with this guy. And then I just make x power 4 minus 1 as the numerator. Right? This guy is numerator. Then x power 8 minus 1 as the denominator. So I bring over. Maybe if I just add in one more step, it will be 1 equals to x power 4 plus 1 times x power 4 minus 1, but I divide by x power 8 minus 1. Then over here, I bring it over. So I get 1 over. Basically, I get the final result here. Does it make sense? I bring it down.
Yeah.
1 divide. 1 divide. Okay, can I this what? 1 over x power 4 plus 1?
Mm.
Okay, good. So now you can have, you square root a fraction means you can square root the numerator. So square root 1, divide by square root denominator, x power 4 plus 1. What is square root of 1? It's nothing but 1. Then what's x times square root of 1? It will become x times 1, which is just x. Oh? So the numerator is now just an x. But the denominator, just nice, is a square root x power 4 plus 1. And there we go. That's our answer. Where f of x is x power 4 plus 1. Can? Yeah, so basically just factorize. But you need to know this trick. Is it okay?
Yeah.
Okay, good. Then question 17a. Sorry, the photo quality not good. This is not a plus. It should actually be a divide sign. Okay.
Oh my god. Okay.
Okay, so let's try the question now. Now that we know it's a divide sign. So over here, what I do is I prime factorize first, sort of. 144. Okay, I didn't exactly prime factorize it, but I realized that 3 over 2 power means you take the square root first and you cube it. This part, okay?
Yeah.
Over 2 means square root. Okay, good. Then square root of 144 happens to be a 12, so it's 12 cubed. But 12 is 2 square times 3, whole thing cubed. So you have to distribute the power 3, sort of. So 2 times 3 gives you 6. Then there's an invisible 1 here. There's a 3 power 1 here. Times 3 gives you a 3. So you get 2 power 6 times 3 cubed. This part okay?
Uh-huh.
Okay, good. Then what I'm going to do is I'm going to replace the 144 with 2 power 6 times 3 cubed. Right, in black ink. Red color to black. Likewise, for my 216, I also, I did a few extra steps. Here, 216 times p power negative 3 raised to the power of negative 2/3. I distribute first. And then I realized that using a calculator, 216 to the power of negative 2/3 is really just 1 over 2 square 3 square. Is that clear?
Wait, 216.
Okay.
Or
I
1
show
over
you.
36. Okay, yeah.
Can, right? Because it's 1 over 36. Yes. Do you know how to calculate 1 over 36 manually?
Meaning like, what do you mean?
How do you know how to show that 216 raised to the power of negative 2/3 is equal to 1 over 36 manually?
On the calculator.
Without calculator.
Oh, without.
Maybe I'll just show you. Here, 216, what you need to first realize is that it's really just 6 power 3. Right? 216 is 6 cubed. You need to know this. Then 3 times 1/3 cancel each other off. You're left with 6 power negative 2, which is 1 over 6 power 2. Then 1 over 36, but if you go a bit faster, 6 is 2 times 3, so 2 square, 3 square. Okay, you distribute the power 2.
Okay.
Okay? Yeah, so that's how I got this. Okay, zoom in, zoom in, zoom in. Right hand side, don't need to change, don't need to change, don't need to change all the way. Leave it alone. Just focus on the left hand side. So whenever you got a divide, it simply means that this is numerator, the left guy is the numerator, right guy is denominator. So what we'll have is 2 power 6 times 3 power 3 times p over 6 power 6, all divided by 1 over 2 square 3 square and times p square. Is this clear?
Okay.
Can Then over here you can simplify it by bringing the 2 square 3 square on top. So that means that we will get 2 to the power of 6 plus 2 and 3 power 3 plus 2. The plus 2 is from this from these two tools.
Yeah.
When it goes up. This part okay?
Yeah.
Then p power 6 over p power 2 is just p power 6 minus 2 if you bring the 2 on top. Okay, good. Then therefore you can simplify 6 plus 2 is 8, 3 plus 2 is 5, 6 minus 2 is 4. So now you can just compare directly, conclude x equal to 8, y equals to 5, z equals to 4. Compare the power. Is that okay?
Yeah.
Okay, that's all for this question. Can next. Question 19, a little bit special. Here we are going to pretend that the particle. Let me read the question. Let me scroll to the question first. Okay, they are talking about a particle. You just pretend that it's like a electron or a proton or whatever, just a ball, and it's moving in a straight line. Let's assume that it is only traveling in a straight line, and this is point A, and there is your point B, straight line. So that means that you don't need to learn a lot of physics. You just need to know that velocity and speed in this context is exactly the same. Velocity and speed is the same thing for this question. Is that okay?
Okay.
Can, good. So that means that they tell you velocity v equals to 10t minus t squared. So you can draw a graph. Okay, y-axis is v, x-axis is t. Then it will look like this: a set phase that passes through 0 and 10. Set phase because negative. Is that okay? Then the middle point, the midpoint. Okay, this one is not very relevant, but I just want to plot it for to make it look nice. It is in the this maximum point is in the middle of the two roots, 0 and 10. So you just take the average of 0 and 10. It's just a 5. So that means the x coordinate here is 5. Then how did I get this 25? How did I get this 25? Do you know?
How?
Okay, when x is equal, when t is equal to 5. Okay, how do I know it's equal to 5? Because this is the maximum point. It's by symmetry lah. It's directly in the middle, in between 0 and 10. The x equal to 5, t equal to 5.
10 divided by 2.
Yes, correct. 0 plus 10 divided by 2. Right, the middle, the in between 0 and 10. Okay, then t equal to 5. So what do you do with t equal to 5? You got a formula here.
Oh.
Exactly, sub in, and then you get your 25. 10 times 5 minus 5 squared. Okay, you get 25. So far, okay? Oh, by the way, do you know how I got the 0 and 10? Can understand how I got 0 and 10? Need to explain?
Okay. Yeah.
Don't need to explain now. Yeah, just equate to 0, then solve. So now what is the question asking you? The question asks you to show that the particle has a speed of 5 meters. Do you know this notation? 5 ms power negative 1 means 5 meters per second. Do you know that?
Yeah.
Yes, okay. Show that the particle has a speed of 5 meters per second or greater for exactly 4 times square root 5 seconds. So speed here, I'm telling you, is exactly the same as velocity. They tell you speed of 5 meters per second. Graphically, what it means is they want you to draw a horizontal line so that v equals to, wrong. V equals to 5. Help me to correct this. V equals to 5. I wrote down wrongly. Okay, v equals to 5.
Okay.
Then when v equals to 5, there's a corresponding time because there's a formula. Time and velocity has a exact formula. So if we know the v, 5 meters per second, we can also know the time. You can think of it like this. The particle is like going slowly, and then suddenly it increases its speed. It gradually increases its speed until it reaches maximum speed over here. And then since it's reaching the end point B already, it starts to step on the brake. So it starts to slow down until it eventually reaches point B and it comes to a rest, 0 speed. Does it make sense?
Okay.
Can you imagine you step on an accelerator, you zoom very fast until the maximum speed in the middle. And then after that, you start to step on the brake and you slow down. Okay, so the question here is asking you, there's a certain speed here. As it speeds up and then it speeds down, there's a certain speed here, which is 5. If it speeds up and as it steps on the brake, you also reach a certain speed 5. So what is they want you to show that the duration between these two 5 meters per second is 4 root 5. So that must mean that we must find the distance between these two t values. Does it make sense?
Okay.
Yeah, so what we should know beforehand is that the time taken is t2 minus away t1. If I just denote the 2 times. This one is t1, that one is t2. Is that okay?
Okay.
Then 5 minus 2 root 5 and 5 plus 2 root 5. How do I get that? Very simple. I got v equals to 5. I want to find the x, what do you call it? The x value of the 2 points of intersection. I just need to substitute v equals to 5. Does it make sense?
Yeah.
Can. So yeah, that's what I do here. I sub v equal to 5 into the equation. Oh, v equal to 5. Then I solve for t. Using quadratic formula, I rewrite it in standard form, right hand side is 0. I solve, I get 5 plus minus 2 root 5. Then from the context, I know that there will be a earlier time t1 and a later time t2. Earlier time must be smaller, so it must be the minus 5 minus 2 root 5. Then the later time is plus. So how do I show that the distance here is 4 root 5? I just need to take t2 minus t1. I subtract, make sure you open up the bracket. So minus 5 plus 2 root 5. Then the minus 5 and plus 5 at the front will cancel off. You're left with 2 root 5 plus 2 root 5, which gives you your 4 root 5. Is that okay?
Yes.
Can?
Yeah.
Yeah, that's how you show it. Okay, done. Then question 20. The careless mistake that you made here is, I believe here, yeah, it should have been a plus. You see that? A squared plus 2ab plus b squared. Because here is a plus, here is a plus. Okay, so it should be a plus. Then everything error carry forward. Instead of minus root 3, should have been a plus root 3. You just check the work later. Should be a plus. Then here error carried forward. Oh, it should have been a plus here, I think. So. And also, when you try to, even if, let's say that I just continue with your wrong working, 1 over 2 minus root 3, it should actually be a plus, the actual solution. But let's just check your working. You made another mistake over here. You wrote down 2 minus 3. Not correct. When you try to when you rationalize, you multiply by 2 plus root 3, right? So it will be a squared minus b squared, which is 4 minus root 3 squared is 3. 4 minus 3 is positive 1 only.
Yeah.
So here should have been a 4 minus 3, which is a positive 1. So you made 2 mistakes here. Error carried forward from the first part and a mistake when you rationalize. So my advice is be patient. Really write down the 2 plus square root 3. Write down the working. Really need to write down. Okay. But anyways, this is wrong in the first place. So this is the correct one. It should have been a plus. Error carried forward. This what I wrote is the correct answer. Then you multiply by the conjugate. Blah blah blah. You'll get the 2 minus root 3. But not done yet, because we need to substitute in the p and the 1 over p. Then after that we simplify. This guy over here is a rationalized version of 1 over p. So you get 2 minus root 3 over here. Bring in the minus sign, and then you will eventually get 2 root 3. Can?
Okay.
Okay, can. That's part 2. Is that all? Wait, there's still one more worksheet, is it? Yeah. Over here again, it's the same trick. Question 21. You have x equals to, I let x equal to a power 1/3. B this time I let it be equal to b power 2/3, not 1/3. Reason being, I saw that there's a 4/3 here, which is really just 2/3 square. B power 2/3 square. So 2/3 times 2. 4/3. And I also saw that there's a 1/3 here, then it jumped to 2/3. So it's 1/3 square. A power 1/3 squared. Okay. I think it's simpler if you do a substitution. So eventually you'll get x plus y times x squared minus xy plus y squared, which is x cubed plus y cubed. Then x is a power 1/3 cube. Y is b power 2/3. Don't forget the cube. Then you'll just cancel off the 3's. You're left with a power 1 plus b squared. Mic test, can you hear me?
Yeah.
Oh, the recording. I don't know what was going on. I heard a recording in progress. Not sure what happened to my audio. Did you hear me when I was explaining this part? Yeah, so you let x equal to a power 1/3 and y equals to b power 2/3. Then you just sub in accordingly. You get in terms of x and y. No more fractions, just whole number power 1, 2, 2. Then you can immediately see that it's x cubed plus y cubed. Then you sub back in. Then you solve it in terms of a. Is this okay?
Yeah.
Can good. Moving on. Everything correct so far? Okay. This one a little bit challenging, and I need to talk about the 2014 paper question 3. Paper 2 question 3. So over here, 4 minus root 3 equals to square root a plus b root 3, right? You want to solve for a and b. Not easy, not easy. What you need to do is to realize that the a and the b is trapped underneath a square root. So what do you need to do?
Square.
Exactly, you need to square both sides. Every time your variable is trapped underneath the square root, then you need to square both sides. So let's see what we can do here. 4 minus root 3 bracket whole thing square. You cannot, it is not the same as 4 square minus root 3 square. You know this, right? You cannot just distribute over a minus.
Yeah.
So, yeah, it's a minus b bracket square. It's a square minus 2ab plus b square. You need the extra minus 2ab. But let's just write out everything first. So square the square root. They will cancel each other off. Then you are left with a plus b root 3. Let's simplify the left-hand side. So we get 4 squared is 16 minus 2 times 4 times root 3, 8 root 3, plus root 3 squared is 3, equals to a plus b root 3. So far, okay?
Yeah.
What's 16 plus 3? 19 minus 8 root 3 equals to a plus b root 3. So what do you conclude? A equals to what?
19, b equals to -8.
Exactly. That's all. Okay, next. Part B over here. Okay, again is you're almost there, but I think you made a careless mistake. Like you went a bit too fast. A is power x and 2y plus 2. So you subtract already, then you compare it with 1. Here you only subtract 2y. I think you forgot to subtract a 2. You forgot about this plus 2. You need extra minus 2. So that's why everything wrong. Then the b power 6. Okay, you got it right. This second equation is correct. The second equation is correct. Yeah, then error carry forward. I showed you the working over here. You can go and check it yourself later. And you get x equals 7, y equals 2. Can? Yeah, you're just missing a minus 2 here. Otherwise, your working is fine. Over here, you don't need to put down plus bracket minus. It's fine. Even though they ask for a plus b root 3, you don't need to show it precisely like this. 6 minus 2 root 3 is also okay. This is okay. 6 minus 2 root 3 without the bracket is also okay. Without the plus. Both are okay. Can? Yeah, all right, moving on. Question 30. It is a horrible idea to be squaring both sides of this equation. No. Oh, so complicated. So scary. You factor out a square root 6, and then you write down 2x minus 1. Then you realize it's a minus b, and then you square both sides. It will work, but it gets a bit complicated unnecessarily. Let me show you a simpler way. Here, what you need to realize is that here is x on its own. Is it trapped underneath a square root or not? Are they trapped underneath a square root? No, that means that this is what we call x power 1, x power 1. They are called linear expressions. Here, the only thing about the square roots is the coefficient. So it's just a number. It's as if you're solving a Sec 1 equation. Sec 1 students do this, like x times 7 equals to x times 5 plus, I don't know, 3. Then solve for x. How to solve? How to solve?
Move the x times 5 to one side.
Maybe a nicer way to write it is 7x and 5x plus 3, right? Just swap the order because that's the usual way that we see it.
Yeah.
Then move the 5x over. So 7x minus 5x equals to just a 3. Then 7x minus 5x, how do you write that? It's 2x, right? Right? But how do you get 2? It's really just 7 minus 5 bracket x equals to 3. Then how do you solve for x? You divide by the 7 minus 5. Why am I doing something so extra? Why I write 7 minus 5? Why I don't want to just simplify to 2 straight away? Because I want you to see a pattern. Now we move on to the actual question. Instead of a 7, 5, and 3, we got square root 24, root 3, and root 6. Can you see that we're gonna do the exact same thing? Can you see that?
Yeah.
Can, right? The x root 3 you bring over is just minus x root 3. You got x, you can factor out the x, sort of. Here we got 7x, you bring the 5x over, you get 7x minus 5x. It's sort of factoring out the x, right?
Mm-hmm.
But that's of course, if it's just 7 and 5, you can just subtract straight away to get 2 lah. But here I purposely did something a bit special. I factor out the x because that's the only way that you can do it in this search question. You need to factor out the x. Just think of it as like 7 apples minus away 5 apples. So this is just 7 minus 5. Is that clear?
Yeah.
Clear to hear? Some students get confused by this. Is it clear to you? Can
Yeah.
Then the right hand side is just root 6, leave it alone. Then what you do now, root 24 minus root 3, bring it over. So divide over. Then root 6 over square root 24 minus root 3. You can simplify, you get root 6 over 2 root 6 minus root 3. Then you just rationalize denominator, blah, blah, blah. You eventually get to 4 plus root 2 over 7. Then the answer is a equal to 4, b equals to 2. Is that clear? Can Okay, good. Don't need to square both sides. No. Wow, very bad, very scary. I'm not gonna check this. Don't square both sides, okay?
Okay.
Yeah, square it only if necessary. You've done a lot of practice questions on squaring. You should understand that it is very painful. Okay, you should understand that this is very painful and very long-winded. Only do it if it's absolutely necessary. When the x is trapped underneath the square root, underneath the square root. You have to square both sides 2 times. Square 1 time, square another time. Wow, very painful. Don't do it. Unless you really need to. This one you really need to. Okay, finally done. Okay, good. So what's the next one? Let me find the worksheet. Hold on a second. Should I talk more about certs or yeah, I'll just talk more about certs. Finish all the worksheets that I planned to go through. Let me find the worksheet first. I sent you all the files already, right? Like I send it all on Telegram, all in one shot. Like
I
1.1,
think so.
1.2, 2,
Yeah.
3, homework 1, 2, 3, 4. Yeah, I sent all those already on. So I'll just read it out by names, then you open up the file. What have we went through already? Let me just double check first. Have we went through the number 3? Topic 1 certs mid-year revision.
I don't think so.
Okay. Then I'll go through that. This one? Have we done it?
Oh wait, no, yeah. Wait.
It looks very similar, but because
it looks very similar.
Okay, I think we haven't done it.
Yeah.
Okay, I'll just go through it. Okay, let's begin. So this is the answer worksheet. I'll just use the answer straight away. Yeah, you can check your question. Let me think. I don't think I should go through all the questions. I should just select some, then the rest will be your homework. Let me see. What's a good question to go through? Which one do you think you struggle with doing? First 5. Okay, 5. Pick one.
Probably like 5.
Question 5. How about question 2? Okay.
I think that one is like just square thing.
Okay, let's go through question 5. Let's go. Let me start. Okay, let's go through question 5. Because the topic is roughly the same. It's just application only. So next one, so for 5 part A, let's take a look. We're going to simplify 2 root 54 minus 3 over square root 24. So first thing, we should try and prime factorize this 54 lah. What would it be? Let's see. 2 power, let me see. 2 times 3 cubed, is it correct? Okay, so if we square root this guy, biggest perfect square I can take out from here would be 3 square lah. So it's 9 times 2 times 3, which is 6.
6.
So square root 9, square root 6, you're left with 3 root 6. Okay?
Okay.
Then 24, how to prime factorize? Or if you're faster, you can see a perfect square that can be factored out. Perfect squares are 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25. 25 is bigger than 24, we don't need to look at it. Can we factor out any perfect squares from here?
4.
4, so we can rewrite as 4 times 6. So square root 24 is square root 4 times 6, which is square root 4 square root 6. What's square root 4? 2. What's square root 6? Cannot simplify. Leave it alone. 2 root 6. Okay so far?
Yeah.
Okay, good. Then now we can simplify. 2 times square root 54, we already figured out is 3 root 6. If you're faster, you can multiply 2 and 3 straight away. I'm a bit slow, so I don't want to. I am scared I make careless mistakes, so I don't do it. Then square root 24 is 2 root 6, so I write it down. 2 times 3 is 6, so 6 root 6. Minus away 3 over 2 root 6. What's the conjugate of 2 root 6? Top and bottom multiply by what?
Times root 6.
Correct, yes, just root 6. The goal is what we call rationalizing the denominator. Here, square root 6 is not rational, cannot write as a fraction. We want to make sure the denominator, the bottom of this fraction, can be written as it's a number that is rational. Sorry, we need to make sure that the denominator is a rational number, meaning we can write down that number at the denominator as a fraction. So root 6 times root 6 is what? Just a 6. Then multiply by 2 is just a 12. So is 12 a rational number?
Yeah.
Yes, whole number. Okay, so 3 root 6, just multiply. Then you want to I think you want to combine it into one single fraction. So before that, let's just cancel off a common factor. Then we are left with 6 root 6. Oh, we want to add with a minus, subtract away a fraction with denominator 4. So we multiply by 4 on the top and bottom. We get 24 root 6 over 4. Minus away 1 times root 6 over 4. Simplifying, we get 24 minus 1, 23 root 6 over 4. 23 and 4, any common factors? Don't have. So we leave it. And that's our answer.
Okay.
Okay, and then part B. Root 5 minus root 2, all divided by 2 root 5 plus 4 root 2. So how to rationalize this? I think you can tell this is not rational, right? Got square roots. So straight away multiply top and bottom by what?
By conjugate.
The conjugate, what is it?
2 5 minus 4 root 2.
Correct. Good. Yeah, then the denominator, I'll just do it step by step. It will become a square minus b square. Oh. Like a plus b times a minus b gives you a square minus b square. Then the numerator, okay, I'll just do it straight away. Root 5 times 2 root 5. Root 5 is 5. 2 times 5 is 10. Root 5 times negative 4 root 2. Minus 4 times root 10. Do you know how I got this root 10?
Root 5 times root 2.
Yeah, just combine them. Huh? Root 5 times root 2 is just square root of 5 times 2. So it's root 5 times 2 is 10. So it's root 10. Okay, you know that. Good. Minus root 2 times 2 root 5, you get a minus 2 root 10. Minus root 2 times minus 4 root 2 is positive 4 times 2, which is 8 plus 8. Can? Okay. Then simplify the denominator. Oh, by the way, do you know that at every step along the way, you can just check with your calculator. You type this entire line inside the calculator. Okay, wait. Let me see how I can do this. You just let me send this to you on Telegram. Hold on a second. Are you copying down as I type, as I write? If not, never mind. Let me just resume share. I want to share my calculator. I can just. Can you see my calculator?
Yeah.
So I also sent you on Telegram the question the what I've written so far. So what I mean is every step along the way you can actually check with a calculator whether your answer is correct or not. So here's how I'll do it. The answer that I eventually got was what, 10 minus 4 root 10. So I'll just type that in the calculator. Minus 2 root 10, just type in the calculator. Then plus 8. I'll get a bunch of decimals. Oh, this calculator is special. It can calculate for me the exact value because it's more modern. But some calculators cannot. So you just display the decimals. This is fine. The decimals is fine. Okay, that's the numerator of the second fraction. But how about the numerator in the original line, the first line? It's actually just square root 5 minus 2. Square root 2. And 2 root 5 minus, 4 root 2. Check, is it the same? Press up, press down. Same?
Yeah.
Same, okay, then that means we're correct. You can also check the denominator. 2 root 5 4 root 2 multiplied by 2 root 5 minus 4 root 2 negative 12, then check the a square minus b square. Whoops, the bracket in the wrong place. Wow, this is so slow. Minus, I need to open a bracket first. Oh my goodness. Do you get the same answer?
Yeah.
Yes, both are negative 12, then that means confirm we're correct. And in fact, you don't even need to show the working. Here, the a square minus b square. You can just type in a calculator, you get negative 12 straight away. Oh, okay. Okay, come back to the actual iPad screen. Hold on a second. I need to open up. Yes. So the denominator eventually you don't even need to calculate Just use a calculator. You get negative 12. If you want, I show you the working quickly. So 2 square times root 5 square is 5. 2 square times 5 is 20. Minus away 4 square times root 2 square is 2. 4 square 16 times 2, 32. Minus 32, negative 12. Okay? Negative 12. Okay, I'll just use a calculator. I think if once you get used to the calculation, I think you can, as practice, this one just for practice, then eventually you'll just upgrade to a calculator. Just use a calculator. Okay, then simplify the numerator. This one cannot use calculator because we want exact form. So it's 18 minus 6 root 10. Okay, actually you can on my calculator. It's smart enough to give me the exact answer. So depends on your calculator. Okay.
Okay.
Okay, can then now simplify. This one you can rewrite it as what did the question ask? Simplify. Okay, we can't. Okay, I'll just have to factor out a negative 6 from all of them. So this one becomes a positive square root 10, and this becomes a negative 3. Divide by negative 12. Cancel off, become positive 2, and we get our answer root 10 minus 3 over 2. Can?
Okay.
Okay, good. Okay, question 5 done. Move on. They're all pretty much the same. I'm gonna. Do you think question 9 is okay? Okay, then I'll go through our question 10. Okay, let's try our question 10. We have to reject 4 over 9. Yeah, you know the procedure already. Okay, let's go. So this one, solve the equation, blah, blah, blah. Oops. Okay, just solve this equation. So 2 root x equals to 1 plus square root of x plus 5. How do we do that? How do we solve this? We need to isolate one of the square roots on its own. Or at least it has to, or at most it can have a scalar, sorry, it can have a coefficient in front of it. You basically need a single term, only a single term on one of the sides. Here we satisfy that condition, so we are allowed to square both sides of the equation. Take note that a plus b square is not a square minus b, a square plus b square only. You still need a plus 2ab. So let's just expand it. This will become 4x, right? 2 square is 4. Then this one becomes 1 square 1 plus 2 times 1 times square root x plus 5. I skipped the times 1. Then plus square root x plus 5 square. If you want, you can just cancel off straight away and write down the, oops. You can cancel off the square root and square inside your head and write down x plus 5 directly. Okay, so now how? You got another square root. The x is trapped underneath. You need to leave this alone. You need to isolate this term. So what we're gonna do is we're gonna make 2 root x plus 5 the subject. So we get 4x minus 1 minus x minus 5. Simplify, 4x minus x is 3x, minus 1 minus 5 is minus 6. Okay, 2 times root x plus 5. I noticed that I can factor out a 3. But there's really no point to doing it. No point. So we're just going to square both sides again. Square, square. The numbers are not too big. You factor out the 3 or not, it doesn't really matter. So 2 square is 4. Then square root and square, they cancel off. You're left with x plus 5. But make sure you have brackets. Then this square will become 9x square. Right, 3 square is 9. Minus 2 times 3x times 6. 2 times 3 is 6. 6 times 6 is 36. So minus 36x. Plus 6 square, 36. Clear so far?
Yeah.
Then distribute the 4, we get 4x plus 20 equals to 9x squared minus 36x plus 36. This is a quadratic. What do you need to do? Make sure everything is on one side, all the variables on one side, equals to 0 on the other side. So 9x squared minus 36x plus 36. You bring the 4x and 20 over, you get minus 4x minus 20 equals to 0. Simplify. 9x squared minus 40x plus 36 minus 20 plus 16 equals 0. Anything to cancel? 9, 40, 16?
No.
No, then just use a calculator already. So yeah, usually if we can get exact answer using a calculator, then just use the calculator. But if cannot, then you resort to the quadratic formula. So x equals to, okay, if I want to pretend that I actually factorize this, I can write down 9x minus 4 times x minus 4. You can expand this manually and check that they are the same. Of course, I actually got this from the calculator and I just work backwards. So x equal to 4 over 9, x equal to 4. Can we accept both answers?
No, must sub in.
Exactly. Correct. So we're gonna check over here. Sorry for the messy writing. I draw an arrow because I ran out of space at the bottom. X equals to 4 over 9. Let's check this. So what happens? Straight away, I can tell that underneath the square root, they will both be positive. So I don't have a shortcut. Cannot reject straight away because that's square root of negative. So I really have to check the LHS and the RHS.
Yeah.
Let's just check. Original equation didn't have the square. Just take note. So 2 times square root of 4 over 9 on my calculator, it gives me a 4 over 3. Then on the right hand side, I get 1 plus square root 4 over 9 plus 5. That's a 1 plus 7 over 3, which is, and they're definitely not equal. Therefore, x equal 4 over 9, you have to reject. Then next, you check the other solution, which is x equals to 4. Again, you cannot reject them because the underneath the square root, you don't have negative. I think it's quite obvious. I don't need to check that. Then you have to check your LHS and RHS. LHS is 2 times the square root of 4, which is 4. Right hand side is 1 plus square root of 4 plus 5. 4 plus 5, 9. Square root 9 is 3. 1 plus 3 is 4. Okay, also equal to 4. So they are equal. Therefore, x equals to 4 is accepted. Reject, accept. And that's our only solution. Can?
Yep.
Can? Okay, good. Maybe I should just do multiples of 10. Multiples of 5. All these questions you can handle, right? I think.
Oh, I hope so.
Okay. Which one looks difficult to you? Pick one.
The 14, I guess.
14. Okay, let's go through 14. Because they are all the same questions, honestly. Just rationalize the denominator only. And your a plus b bracket square, a minus b bracket square, a square minus b square. You know all this already. Okay, simplify. 6 minus root 3 over 3 minus square root 3 bracket square equals to what? First thing you notice is that there's a square here. So there's a few ways that you can tackle this. Let me show you the first way. First way is just expand the denominator. So you get a squared 9 minus 2 times a times b, which is 6 root 3. 2 times 3 times root 3. Plus root 3 squared is just a 3. Simplify a bit more. 6 minus root 3 divided by 9 plus 3 is 12 minus 6 root 3. Simplify a bit more. Don't straight away go to rationalizing denominator. Simplify a bit more. What you realize is you can factor out a 6. 2 minus root 3. Then 6 minus root 3. What's the advantage in doing that? I was hoping that they can cancel off, but they can't, so no choice. But it's still an advantage because what we can do now is we can factor out the 1 over 6 and focus on 6 minus root 3 divided by 2 minus root 3. So far, so clear?
Okay.
Then what do? Start to rationalize. So multiply top and bottom by the conjugate. Minus become plus. Minus become plus. Yeah, then the 1 over 6, you can leave it alone. So now we don't have to deal with such big numbers. Okay, what a coincidence. If you multiply 2 minus root 3 by 2 plus root 3, you just get 4 minus 3, which is 1. So denominator is just a 1. What a coincidence. Makes things very nice. Then you can divide by 1 means you're just left with the numerator. We'll write that down in the next line. Then 6 times 2. Well, 6 times root 3. 6 root 3 minus root 3 times 2. Minus root 3 times root 3 is a minus 3. So 1 over 6. Then don't need to write the denominator anymore because divide by 1 can just leave alone. 12 minus 3, bracket 9. 6 root 3 minus 2 root 3, 4 root 3. Then simplify. I can't simplify it much, so I'll just leave it as this format. You can also rewrite it as this format. 9 over 6 plus 4 over root 3 over 6. Oh, actually, yeah. Then you can divide by 3 on both sides for 9 over 6. You'll get 3 over 2. Then the next one, 4 and 6 cancel off a factor of 2. You're left with 2 root 3 over 3. Or you could put the root 3 down in the middle like this. Make sure you don't write it all the way at the bottom. This doesn't look so good. Bring it a bit more to the middle. Bring the root 3 a bit more to the middle. Don't write it so low. Write it a bit more to the middle or put it on top directly. Okay? You get the a plus b root c format.
Oh.
A plus b root c format. Not required in all questions. This is fine. This is also fine. This is also fine. Okay, that is method 1 by expanding directly. Now I'm going to show you another method, which is to rationalize the denominator straight away. Let me just try, let me label this as method 1. I'll try method number 2 now, which is to rationalize the denominator straight away. Okay. So what I'm going to do is I'll multiply the top and bottom by 3 plus root 3. But take note that this is power 2. So if I want to attack whatever is inside the bracket, I will need to have armor. I need armor, protection, power 2, protection, power 2. Does it make sense?
Okay.
I think of this it's like a tower, some sort of entrance fee, huh? You must have the same power so that the insides can interact with each other. 3 minus root 3 can multiply by 3 plus root 3. Okay, so basically what it means is that after you expand the denominator, you can actually get 3 minus root 3 multiplied by 3 plus root 3, but you factor out the power 2. Does that make sense?
Yeah.
Okay, good. Then this one you can just multiply. Maybe I'll multiply it later. Too many things already. I'll just write down first. But the denominator, what's a minus b times a plus b? A square minus b square. So it's really just 3 square minus root 3 square, which is a 9 minus 3, which gives you a 6. But don't forget that there's a square, so we get 6 square. Simplify, we get 36. Later, then we write down the 36. But here, the numerator, we expand. 6 minus root 3 multiplied by a square plus 2ab plus b square. So 9 plus 6 root 3 plus 3. Simplify a bit more. 9 plus 3 is 12. 12 plus 6 root 3. Is it clear so far?
Yeah.
Can Okay. Then continuing. Notice that there's a factor of 6 I can factor out here. What's so useful about that? The 36 at the bottom can cancel off, right? Can you see that? 6 and 36. Yeah, then you're left with 1 and 6. Okay, simplify a bit more. What we will get is the numerator divided by 6. Okay, let me just clean up a little bit. Ayo. Like this. Okay. Whoops. Can clean up a little bit already. Then we can simplify a bit more, multiply out. 6 times 2, 12. 6 times root 3, 6 root 3. Minus root 3 times 2, minus 2 root 3. Minus root 3 times positive root 3, negative 3. Divide by 6. Simplify. 12 minus 3, 9. 6 root 3 minus 2 root 3, 4 root 3. Divide by 6. Answer. Same answer. Clear so far? Can? Okay, good. So that is method 2. Method 2 is non-standard. You go and put a square. Usually you would want to make sure that the denominator is just in this format. A minus b times square root, or a plus b times the square root. And then it's just power 1. There's no power basically. Okay. Okay, next, let's see. I think the rest you can handle. It will be homework. 15, should we go through? Okay, there's only 15 questions here. Okay. Anything else you want me to go through in this worksheet? If not, the rest will be homework.
Okay.
Can? Okay, this one a little bit challenging. Maybe I'll give you a hint. Here, 27, you prime factorize it as 3 cubed. So it's really just 9 times 3. So square root 27 is square root 9 times 3, square root 9 square root 3. This is just 3 root 3. Likewise for your square root 48. I think it's 16 times 3. Yeah. So square root 16 times 3 split up as square root 16 square root 3, which is 4 root 3. Square root 16 is 4. Okay, then I think that's enough hints for you to solve the question already. Multiply. Okay, then the rest will be your homework for this one. Okay, next worksheet. Let's see. What is the next worksheet I want you to solve? Is it homework 3? Let me see. Let me check first. What's the next worksheet I want to go through? Oh, that's all the worksheets I have 1, 2, and 3. Oh, and then after that, I have the homework questions. Have I assigned HW2? I haven't. Okay, that one is challenging a little bit. Okay, let's just go through that instead. Homework 1. Homework 1 sent already. Homework 2. This one will also be a homework. Let's see. Okay, I'll go through some of the challenging questions here. Question 3. Okay, maybe question 4. Just try, not that challenging actually. Question 8. Okay, I'll go through that. Question 9. Question 10 is okay. Question 11. You know what's a perimeter?
Like the sum of all the sides.
Yes, correct. So length and breadth. Here you got L, here you got B. So it's really just 2 times L plus B. Or 2L plus 2B. Can? Perimeter.
Okay.
Can? Then you can do that question on your own. Question 12. Area of rhombus. This area, length of one of its diagonal is blah, blah, blah. Find the length of the other diagonal. So giving your answer in the form of A plus B root 3. This one, okay, I go through. You need to understand properties of quadrilaterals, in particular for rhombus. Oh, this one also non-standard. Every time you see a power, and then you see a minus or plus in between, right? You know it's a non-standard question. You need to do factorization. You cannot use any of the exponent rules anymore because the exponent rules only applies to multiplication and division. Here you got minus, you're in trouble. Need to be creative. Question 14. Okay, I'll go through also. Then, question 15. I'll leave it as a challenge. Question 16. I'll leave it as a challenge. Quadratic equation you need to solve. Question 19. I'll leave as a challenge. A bit difficult. Part A at least. Part B is after I go through the previous part, question 13. I hope it should be okay. Question 20. I think you can do it. Okay. Yeah, that's all. Okay, good. Then let me start. Okay, the rest are all quite standard. Oh. This is homework 2. It will also be part of your homework. Okay, let's try question 3. Given this is homework 2, HW2. Given that the diagonal of a square is blah blah blah, calculate p square where p is the perimeter of this square. Giving your answer in the form of a plus b root 2. A and b are real numbers. So what you need to do straight away when you see square, what do you do? Next question. You see square.
What?
What should you do?
Yeah, what?
Okay, draw a square. You see a bunch of words, but you see a square. I hope that this is inside your head. A picture of a square, okay? And translate it onto a paper. And use more space. Use more space. Don't need to draw so small one. Draw a square. Then they tell you the diagonal. So what's a diagonal? Like this, or the other one, diagonal. Just draw one is good enough. Then we label the length. They want you to calculate p square. P square equals question mark. That's the goal. Then p is the perimeter. How do you find perimeter from diagonal?
Pythagoras. No.
Can. Yes. Let's call the length x. What do we know about all 4 sides of a square?
Same.
Yeah, same. So we'll have x and x and x. What do we know about the angle over here?
90.
90 degrees. So what shape do you see here? What kind of triangle?
Isosceles.
Isosceles.
Right angle triangle.
More importantly, right angled triangle. So we can use what theorem? Pythagoras theorem, exactly. Because right angled triangle. Okay, so what do you get? Let's just denote this diagonal length as d. D for diagonal. So d equals to this monster fraction. What do we have? Pythagoras theorem.
X squared plus equals to
Think about it.
b square.
X squared plus x squared equal to d square. the sum of the square of the shorter sides. Sum of the square of the shorter sides. X and X are short equals to the hypotenuse square. The hypotenuse, the diagonal. The longer side. Oh, by the way, did you know that in a triangle, the larger the angle, the longer the length? Makes sense, right?
Okay.
Yeah. Increase angle, increase length of opposite side. Right? The angle is here, the opposite side is there. Longer, bigger angle, bigger length. Shorter angle, shorter length. Oh, by the way, also just a bonus triangle fact. Do you know about the triangle inequality? The triangle inequality rule.
No.
Triangle inequality tells you that if you have three sides of a triangle, let's call them length A, B, and C. Denote them A, B, C. The sum of any two sides must always be bigger than the third side, longer than the third side. So A plus B, B plus C, and the last one is A plus C. Must be bigger than A, must be bigger than B. Did you realize that?
Okay.
It makes sense because you see, think of a windshield wiper, like if you can imagine a rectangle like a car, then you got the when it's raining, you have to have the windshield wiper swiping left and right. Okay. If you got a length that's, let's say, 5 here, and then you have a length here, let's say 4, then you want to construct a triangle. So you can imagine this 5, you tilt it upwards. So now it becomes over here, length 5. And the length 4, you tilt it upward like a windshield wiper. You can imagine a circle of radius 4, another circle of radius 5. You see length 4 and length 5, right? Can you form a triangle?
No.
I know, right? It's too short. You still need an extra bit here and an extra bit there. So that's why you see over here, this guy is 5 plus 4. Then what is it? That means that in order for you to form a triangle, which is this triangle here, this length here is 5 plus plus. 5 plus plus plus. This length here is 4 plus plus plus. So what you notice, 5 plus 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 add on with 4 plus 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 must be bigger than 5 plus 4. Does that make sense?
Okay.
So in order for you to construct a triangle, you need a length 5 add on a bit more, length 4 add on a bit more, which will be bigger than 5 plus 4. It must be 5 plus 4 here because of how I constructed the triangle. Right, 5 and 4. So that's the triangle inequality already. The sum of these two sides, the pink sides, must be longer than the third side. This works for all triangles. So you can check with this triangle. This is a right angle triangle, by the way. 5 plus 12, is it bigger than 13? 5 plus 13, is it bigger than 12? 12 plus 13, is it bigger than 5? All true, right? Yeah. If you don't satisfy any of these inequalities, the triangle will be impossible. You cannot construct the triangle. Okay, this is called triangle inequality. Okay, just a bonus fact. Okay, anyways, back to the question. X squared plus x squared equal to d squared. So we get 2x squared equals to d squared. What do we want to find actually? Let's think about it. What do we want to find? Calculate what? How's the goal?
Find d square.
Huh? No. No.
Wait, find p square.
P squared. What's P?
P is the diagonal.
Huh?
Wait, P is the perimeter of the square.
Perimeter. Okay, very good. Where P is the perimeter.
Actually, you want to find 4x.
Very good. Yes, where P. So of course, if its perimeter is actually 4x. So what? No, we're not trying to find 4x. We're trying to find 4x
Square. 4x
square. So let's figure out what is. Oh, sorry. Let me move away my triangle inequality. So what we're actually trying to find here is p squared, which is 4x bracket square, which is 16x squared. Okay, good. So what we have now is 2x squared equal to d squared. Let's don't just go in a rush to find the d squared straight away. Let's be a bit smart. Know the goal at the end of the day. It's 16x squared. You got 2x squared. How do you go from 2 to 16?
Times 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 8.
Times 8, yes, 2 times 8 is 16. Good. So if you times 8 on the left, you also times 8 on the right. So 8d squared. So that is our actual goal. We have translated our problem from p squared into 8d squared. Clear so far?
Okay.
Okay, so now our goal is to find 8d squared. You got d. So the question is really simple. They are just indirectly asking you to find 8d squared. So let's just present it nicely. P squared equals to, no space. Okay, never mind. I'll just write it at the bottom. So p squared equals to 8d squared. Maybe I should write it as 4x squared, which is equals to 16x squared, which is 8d squared, which is then equals to 8 times d squared. What is d? Copy and paste the fraction down. Well, you could just use a calculator. If you have a good calculator, they can calculate it for you. Let's just see. I'm gonna send it to you on Telegram, what I've written so far. Let's see if my calculator can handle this. Let's see if my calculator can handle this. Let me share screen. Share calculator here. Okay, I sent you the working already, so you can have a reference. So what is it? We want 8 multiplied by a fraction. What's on the fraction? 1 minus 5 root 2 divided by 4 minus 4 root 2. Close the bracket, then power 2 equals. Unfortunately, my calculator cannot handle such big numbers. So it gave me decimals. Okay, it gave me decimals. On more powerful calculators, they are able to give you the exact square root value. Oh, so no choice, we have to do it manually. Okay? Is that clear?
Yeah.
Yeah, so yeah, because okay, I go back to my iPad first. Because in this question, they ask for exact value. So yeah, we can't use the calculator value. If it was just that easy, we just need to key in the calculator, just now the 107, that would be our answer. But they actually ask for in the form of a plus b root 2, so we need to manually calculate it. Okay, let's just go ahead and simplify this. So I noticed straight away 4 and 4 can factor out of 1/4. So get 1 minus 5 root 2 over 1 minus root 2 square. Multiply 1/4 square becomes 1 over 16 times 1 minus 5 root 2 over 1 minus root 2 square. Okay, I skip a step. 1/4 square is 1 over 16. Is that clear to you?
Yeah.
Can Okay, then 8 over 16 is just 1/2. Then multiplied by this one, no choice. I have to expand already. So let's just do it. So 1 minus 2 times 1 times 5 is 10 root 2 plus 5 root 2 square is 25 times 2, which is 50. Divide by 1 minus root 2 square. So 1 square minus 2 times 1 times root 2 plus root 2 square is 2. Simplify. 1/2 multiplied by 51 minus 10 root 2 divided by 3 minus 2 root 2. Clear so far?
Okay.
What do you need to do next? Rationalize. 3 plus 2 root 2. 3 plus 2 root 2. Denominator, can you help me to calculate what's the denominator?
Minus 9 minus 8 is just 1.
Oh, it's 1. Okay, very good. Then meanwhile, I'm expanding the numerator. I think you know how to do this, right? Root 2 is 2 times root 2 is 2, so 20 times 2 is 40. I'll simplify straight away, minus 40. Can? Don't forget the half times, divide by 1, can throw away. Don't forget the bracket. Once you remove a fraction, once you drop the fraction, you have to put bracket because the half needs to be distributed. The fraction, the beauty of writing a fraction is that you don't need to put brackets. But once you drop the fraction, like because denominator is a 1, you throw away denominator. you have to put in the brackets already. Yeah, so 153 minus 40 is 113. 102 root 2 minus 30 root 2 is 72 root 2. Is that clear?
Yeah.
Okay, then we can simplify. So 113 over 2 plus 72 over 2, that's 36 root 2. Simplify this one, it's 56.5 plus 36 root 2. Okay? Okay, so what's your so you can answer the question now. They are asking for give your answer in the form of a plus b root 2. So that's the answer. 56.5 and 36. Is that okay? Is that okay? Any
Okay.
questions? Can yeah, a plus b root 2.
No.
So that's not a. Okay, good. That's your a, that's your b. Okay, good. So what's challenging about this question? What do you find challenging about this question? If you had to do it yourself.
I will probably solve for like the wrong thing.
Okay, so you it's question reading, that's your problem, is it? Okay, then to help you with that, I think it will be useful if you write down the goal, GOAL. Oh, then list down everything that you know. P is what? X is what? Oh, I should also label. Let X be length of square. Sorry, I'm a bit caveman now. Let X be the length of the square. I'll just drop my prepositions. I hope you understand what I'm saying.
Yeah.
Yeah, can. Okay, that's question 3. Okay, next one. Okay, 20 more minutes. I hope I can finish on time. Okay, I'm gonna skip this question 4 due to time constraint. I think I'll leave this as homework. You can do it. Then question 8. Okay, I'll also leave it as homework. I think this one is fine. It's just evaluating. You just need to rationalize the denominator. And you need to understand that square root 48, square root 27, square root 12, they can be simplified. Prime factorize, then rewrite it. Like square root 27 is square root 9 times 3. So square root 9 square root 3, which is 3 root 3. You know this, right? How to simplify?
Yeah.
Then I'll leave that to you. Question 9. Okay, this one I go through. Question 9. Let's go through this one. I think you start a new page. Paste here. This is question 9. Let's begin. So question 9, we got k equals to 1 over 1 plus square root 3. We also have you want to express k square over k square minus 1 in the form of a plus b root 3 over 3. How will we do that? I think it would be nice if we just find out what's the numerator and denominator first. If not, we'll be writing something like k square over k square minus 1. And then we got a fraction square over a fraction square minus 1. Very messy, you see. Fraction and a fraction, very, very messy. Confusing as well. And it takes up a lot of paper space. So what I'm going to do is shrink it down. I'll solve for the numerator and denominator separately. Then after that, I will simplify. Let me just get my charger real quick. Hold on a second. Yes, correct. Oh, not recommended to rationalize k. No. You know why or not? Look at the goal. K square, k square. You rationalize already, end up you still need to rationalize again. No point. So we should find k square first. Then we rationalize. Yes, k square is 1 over 1. A square is 1 plus 2 times 1 times root 3, 2 root 3 plus root 3 square is 3. Simplify 1 over 4 plus 2 root 3. I notice as a factor of 2. I'll take it out first. 2 plus root 3. Can?
Okay.
Then I proceed to rationalize. Okay. So yeah, then you multiply top and bottom by 2 minus root 3 2 minus root 3. Sorry for the messy presentation. Don't forget the factor of half in front. Then you're left with 2 plus root 3 times 2 minus root 3, which is actually a 2 square minus root 3 square, which is 4 minus 1. 4 minus 3, which is 1. Numerator is 2 minus root 3. So 2 minus root 3 over 2. Okay? Clear so far?
Okay.
Okay, good. K squared, not done yet. Still got k squared minus 1 in the denominator. So we are going to find out the k squared minus 1. K squared minus 1 is just 2 minus root 3 over 2. I'll just use the simplified version. Then minus 1. Simplify. 2 minus root 3 minus away 2 over 2 divided by 2. Make the denominator the same when you subtract fraction. So 2 minus root 3 minus 2, the 2 will cancel off. You're left with a negative square root 3 divided by 2. Clear so far?
Yeah.
Okay, so therefore we can answer the question k squared over k squared minus 1. Unfortunately, there is still a fraction and a fraction, but luckily for us, denominator 2, what happens?
Times 2 times 2.
Okay, times 2. Okay, yeah, times 2 over 2. Then 2 and 2 cancel, 2 and 2 cancel. What are you left with? 2 minus root 3 over minus square root 3. Oh, so now you know. You're just taking the numerators. Whenever the denominator is the same, you can cancel them off essentially. You see that?
Yeah.
Okay, that's just a shortcut. Doesn't really matter. But we are not done yet because correct, rationalize. Okay, don't need to explain already. Okay, good. 2 root 3 minus 3 divided by negative 1, so 3 minus 2 root 3. Okay. All right. What's the did I do something wrongly? Let me just double check. I missed out a factor of 3. Right, if you look at the answer, 3 minus 2 root 3, there's a divide by 3. I did something wrongly. Uh-oh. Can you see my mistake?
Is it?
Where? Right, correct. Root 3 times root 3 is 3. Sorry. Much better. Yes. So it's 3 minus 2 root 3, then divide by positive 3. Then that's our answer. Yes. Okay. Sorry. Didn't see that. Okay. Okay, question 9, not too bad, no? Not too bad. Just long-winded. Maybe I should write down some notes here. Square first. Rationalize later. Rationalize later. Don't rationalize. This one is not wrong to rationalize, but it's just slow. Don't rationalize the k yet.
Okay.
Don't rationalize the k. It's not so efficient. Okay, I'm just teaching you the fastest way to do it. Okay, question 9 done. Next, what's the next one I planned? Question 12. Okay, this one must go through. Okay, this one is properties of a quadrilateral. You have to know quadrilateral properties. If not, you cannot solve this. So how do you find the area of a rhombus? What is a rhombus in the first place? If this is a square, and then you imagine you push it, so now it becomes slanted, such that the length are still all the same. Then you get a rhombus. It's like a lazy square. Okay?
Okay.
Rhombus. How do you find area of a rhombus? You can essentially see that you can split it in half. There are two what we call isosceles triangles, right? Let's say I need to make it bigger a bit. Let's say that I give it some length. Say for example, this is length 8, 8, 8, 8. Then what's the diagonal? I don't know what's the diagonal length. Okay, so I'll just label this diagonal as D1. Do you notice that this is the perpendicular height?
Okay.
So how do you find the area of one such isosceles triangle? Area of isosceles triangle. It will be half times base D1 times height. Correct?
Yeah.
Okay, good. But the rhombus is really just made up of these two isosceles triangles that are congruent. They are the same. You can prove that it's congruent. I'm not going to do it here. It's just SSS. You can see, right? They are the same.
Yeah.
So you can just find the area of a rhombus by multiplying by 2. Area of rhombus will just be 2 times of the previous working. So it's just D1 times H. Agree?
Yeah.
Okay, but wait, what is H? Do you realize that the two diagonals they actually bisect each other?
Yeah.
So that means that H is really just how many copies of the diagonal. Oh, by the way, the diagonals are the same length. So I know it's not clear in my picture. My rhombus looks more like a parallelogram, but the diagonals actually they are the same length.
Mm.
Can you just accept that for now?
Okay.
And also instead of calling it D1 and D2, that's what I was planning to call it D2, but actually you can just call it D1. Just call it D. Okay, don't need the subscript 1. So D and D, both are length D. That means that H here is actually what? H here is actually half of a D. So it's D over 2. Right?
Mm.
Am I correct? I hope I'm correct. Actually, let me think a little bit. I might be totally wrong. Sorry. Oh my goodness, what am I saying? I have to make a correction. Sorry. I have to keep the 1. Diagonals are not equal. Sorry. The diagonals only bisect each other. I think that makes more sense. This is also a rhombus. Right? And I think the diagonals definitely are not the same length. Right?
Mm.
Sorry, the diagonals only bisect, they are not the same length. So that means that there is still another diagonal over at the other corner here. This is D length 2. D is subscript 2. This is D2. So H is actually half of D2. That means that H over here is half of D2. So D2 divided by 2. Conclusion is D1 times D2, then you divide by 2. That's the area of a rhombus in terms of diagonals. Is this clear?
Yeah.
Okay, good. So that means that the area of rhombus you can find out in terms of D1 times D2 divided by 2. I still don't know the length of the diagonal, but from the side lengths, I can figure out what's the diagonal. Because there is another formula for the area of a rhombus, which is just base times height. Can you see why? You can just chop off a triangle here and transfer over.
Yeah, okay.
Then you get a rectangle. So it's just base times height. Okay, I think that's not relevant to this question. So I'm just going to ignore this. I'm just gonna get you to trust me. I already explained this formula, area of a rhombus, D1 times D2 divided by 2. Is that okay?
Okay.
Can Good. So let's read the question now. They tell us that the area of a rhombus. So let me just draw a rhombus quickly. Area, they tell me, is 6 plus 2 root 3. cm square. I'm ignoring units. Length of one of its diagonal is 4 plus 2 root 3. So let's just say that it's this diagonal. We don't know whether it's a long one or short one. Doesn't matter. 4 plus 2 root 3. Then you want to find the length of the other diagonal, giving your answer in the form a plus b root 3. So what we need to use is this formula here. Right? Make sense?
Okay.
We're gonna label the other diagonal as D. So that means that how would you form an equation? What is equal to 6 plus 2 root 3? How do you use this formula?
The equal to 4 plus 2 over 2 root 3. 2.
Yes, very good. Exactly. Okay, good. Then you just need to solve for D now. So yeah, this is the challenging part. I think this is the most challenging part. The rest is all quite okay. Correct, times 2. And D equals to 12 plus 4 root 3 over 4 plus 2 root 3. Anything to cancel off before we start to rationalize?
2.
Yes, correct. Please make sure you cancel off. If not, your life will be very miserable. You will have a lot of big numbers to deal with. Don't do that. So cancel off a factor of 2, then you start to rationalize. Multiply what over what?
2 minus root 3.
Correct, yes. So that means you'll be left with 2 square minus root 3 square, which is 4 minus 3, which is 1. So denominator just a 1. Numerator, 6 times 2. Correct, very good. Yes, let me just copy it down first. 12 minus 6 root 3 plus 4 root 3 minus 2 times root 3 is 2 times 3, which is 6. Here should be root 3. Minus 2 root 3.
Oh, yeah.
Yeah, okay. So it's maybe I write this down. Negative 2 root 3 times root 3 is just minus 2 times 3, which is minus 6. Okay, yeah, minus 6. Then simplify 6. Minus 2 root 3. Yep, correct. Answer. Can?
Okay.
Okay, good. That is diagonals question. Go. Next one. Running out of time. Sorry for rushing. Okay, question 13. Let's go. Okay, I'll copy 14 at the same time. Okay, let's try question 13 first. So question 13 here, there's 3 power x minus 3 power x minus 3 equals to 78 root 3. Challenge here is that there's a minus sign over here. So can you tell me this powers, which is smaller?
X minus 3.
So I prefer to factor out the smaller power. You can also factor out 3 power x on its own, fine as well. But here, well, the reason why I prefer factoring out the negative power is so that over here I won't get negative powers. Do you see that this is just 3 power 3 minus 1?
Yeah.
Can, right? X minus 3 plus 3 is just x. Then x minus 3, 3 power x minus 3 times 1 is just 3 power x minus 3. Okay, good. 78 root 3. Simplify a bit more. 3 power 3 is 27. 27 minus 1 is 26, right? Yes?
Yep.
Okay, good. So now let's see. How do I continue simplifying this? I realized 3 power negative 3. 3 power x minus 3. Isn't that just the same as 3 power x times 3 power negative 3?
Yeah.
So what's 3 power negative 3? It's 1 over 3 power 3. Which is 3 power x multiplied by 1 over, what's 3 power 3? Is it 9? Or 6?
27.
27, very good. Okay, don't get confused. So it's actually just 3 power x over 27 multiplied by 26 equals 78 root 3. Okay, we can continue going on. Going a bit further. I hope you realize that square root 3 is related to 3 power x. Yes, just multiply over. Correct. The root 3 is actually 3 power half. We'll have to compare coefficient later. Compare the powers. So 78, you multiply by 27 over 26. Do you see that? The 26 is at the top, 27 at the bottom. So when we multiply over, we need to flip it around. 27 now on top, 26 goes to the bottom. Is this part okay?
Yeah.
Okay, type in a calculator for me. What is it? ，Go. Type.
81.
Good. So how do you solve this 3 power x? 81 root 3.
81 is equal to 3 power 4. So 3, 4.5. Wait, 4. Yeah.
So what x?
4.5.
Exactly, done. Okay. Or you can put 9 over 2. Same thing. Okay.
Yeah.
4 plus half is 4.5. 4.5. 4 wholes and 1 half. Okay, good. Solve for x already. Let's try question 14 now. question 14. Let me see if I have enough space. Not enough space. Hold on a second. Next page. Paste this here. We're gonna try. Okay, Ken. Let's try question 14 now. So find the positive integers a and b such that a plus b root 3 bracket square is equals to 79 plus 20 root 3. This question is a little bit challenging because you need to solve for a and b, which is not that easy. Let's see. Square straight away you must know a square plus 2ab plus b square. So a square plus 2 times a times b root 3 plus root 3 square equals to the right hand side. Sorry for the bad handwriting. So simplify a bit more. Root 3 square is just 3. So a square plus 3.
Won't this be B also?
Oh, wait. Correct. I am so sorry. I didn't see that. You're correct. Wow. Sorry, didn't see that. Let me correct myself. Let me think of it. Okay, then in that case, I have to rewrite this b root 3, open up the bracket, and you get b square times 3. 3b square. So you get the real part. The parts without the square root, a square plus 3b square. And then you got a 2ab root 3. So just add on 2ab root 3. Can you see that I am purposely writing it in a specific order? Can you see a pattern? Yes, correct. Then after that, you can solve already. Yep.
Oh yeah. I get this a lot where it's like A and B together. How do you type in the calculator? Because I cannot. I'll need to do it manually.
Correct. That is impossible to type in a calculator. Calculators are only capable of handling a single variable on its own with a number at the side and at least power 1. Okay. You cannot have another variable here. This is what we call, if you multiply 2 different variables, 2 types of variables multiply, right? We call this multi-variable. Non-linear. Okay, cannot. You are not allowed to type in a calculator. This is you need to use computer software to help you to solve it. Very difficult. I had to take a module in university to help learn. We just dedicated the entire module to learning how to solve this kind of equation. Okay, cannot. No, calculator cannot handle. Yes, you have to do it manually. And it requires substitution. You cannot use elimination. Substitution required. Must use. Elimination only case by case basis. Quite challenging. So here the trick is to make A the subject, then you sub in. Or you make B the subject, then you sub in. Then solve the equation. Can I leave that to you?
Okay.
Solve. Okay, solve. Solve AB. Okay, show me your working. Okay, that's question 14. Go. Sorry for rushing, but yeah, running out of time. Okay, yeah, that's all the questions I wanted to go through already. No. Still got one more. Sorry, let me just where can I paste it? I'll just paste it underneath here. The question, do you remember the last question I sent you the last night? Yeah, okay, so let me just reference it again on Telegram so you can see it. If you open your Telegram, you will see it. So okay, I'll leave some blank space. Maybe I'll go through this next week. Okay, now this is 2014 paper 2 question 3. Amax TYS. Okay, let's try this question. So question 3, part 1. We have the area of a quadrilateral is 13 minus square root 48. Straight away, I see 48. I will want to rewrite it as 16 times 3. So square root 16, square root 3. When I take the square root of 48, which gives me 4 root 3. Then in the case where the quadrilateral is a rectangle with width 3 minus root 3, so I'll draw a rectangle. What's the width? 3 minus root 3. Fine, without using a calculator, the length of the rectangle in the form of a plus b square root 3. So we want to find out this length here. What is it equal to? Question mark. We are given the area, we're given the width. What do you do to find length? Quick test, can you?
Yeah.
Area, width, how to find length?
Area divided by width.
Very good. So that's the first step. So that means width equals to area divided by length, 3 minus root 3. That's all they want us to find. Okay, then a plus b root 3 format means you need to rationalize the denominator. But before that, replace the square root 48. 4 root 3 divided by 3 minus root 3. Now we want to rationalize this. So let's just do that. Multiply top and bottom by 3 plus root 3. Oh, sorry, are you writing something?
No.
Oh, okay, I'll just continue. So let's continue. So a minus b times a plus b, it's a square minus b square, which is 3 square minus square root 3 square. I'll write it at the side. 3 square root 3 square. So you get 9 minus 3, which is 6. Okay. Then multiply 13 times 3, 39. 13 times root 3, 13 root 3. Negative 4 root 3 times 3, negative 12 root 3. Negative 4 root 3 times positive root 3. Negative 4 times, what is
3.
it? Great, very good. It's not root 3. Root 3 times root 3 simplify to just a 3, which is a 12. Okay, I'll simplify by writing one more line. Replace the 4 times 3 with a 12. Simplify a bit more. 39 plus, minus 12. I think that's a 27. 13 root 3 minus 12 root 3. That's just a single root 3 over 6. That's our answer. Almost. They need a plus b. So you need to split it up as 27 over 6 plus root 3. Maybe I'll write it more specifically as 1 over 6 times root 3. Cancel off a factor of 3, you get 2 and 9. So the answer will be a equals 9 over 2. B equals
1 over 6.
Very good. Yes, exactly. O-level question, you can do already. Very good. 4 marks locked in. 3 part 2, let's go. In the case where the quadrilateral now is a square, here I assume that it's a rectangle. That's not correct. Quadrilateral, you can just assume that, oh wait, no. Here they said that it's a rectangle. Okay, you need to understand that a quadrilateral is a big family of many different shapes, right? Like parallelogram, rhombus, kite, you know all that, right? Square. Then one of them is a rectangle. Now they're telling you that the quadrilateral change into a square, but the area is still the same. So we have to, again, what do you say? When you hear a rectangle, you draw a rectangle. When you hear square, what do you draw? You draw a square. Okay, now please draw. Yeah, okay. Let's just zoom in and label. So what do we know about this square? They say it has a side of very special. This is challenging. 2 root 3 plus c. Okay, so that means that all sides are equal, right? So it's 2 root 3 plus c. So if they tell us area is still the same as 13 minus square root 48, which we already know is simplified as 13 minus 3 root 4 root 3, sorry. How do you solve for c? Can you form an equation? What equals what? Tell me. I write.
Wait, this is what? Wait, what is this?
Area.
Oh.
The area stays the same. They say in the case where it's like if. So pretend that part 1 didn't happen at all. Pretend that there was no 3 part 1. Now it's 3 part 2. Area of a quadrilateral is 13 minus square root 48. In the case where the quadrilateral is a square with one of the sides being 2 root 3 plus c, solve for c.
Okay.
Equals? Correct.
Yeah.
Square, right? Because it's a square.
No,
because it's a square.
I don't know if you can tell,
Length.
but like whenever I read the question, I always like, yeah.
Always
if it's one of those like a lot of like words, then like I always like, yeah.
Always get confused? Or
always misunderstand or like, yeah.
Oh, then you must learn, because that's because you never practice enough questions. You haven't read enough questions. Yeah, you just need more practice. I give you a lot of practice. I think eventually you'll get it. Okay, So the challenge about this question is that when you try to expand this, you'll get a quadratic in C, and it is not a standard quadratic equation. Let's see. Remember that C, if you read the question, the C, they told you it's just a constant. They didn't tell you anything. Okay, fine. So let's just expand this. A square plus 2ab plus b square equals to 13 minus 4 root 3. Clear so far?
Okay.
Okay, simplify, you get 2 square root 3 square, which is 4 times 3, which is 12. Plus 4 root 3c plus c square equals to 13 minus 4 root 3. I know what you're thinking. Oh, c square and c. Then we can just solve a quadratic equation, right? That
No.
could be possible if you know how to solve for c. So let's see how we will do it. This is method 1. I don't think it works. Let's just see first. So c square on the left plus 4 root 3c in the middle, and then plus 12, bring everything over. So minus 13 plus 4 root 3. We simplify straight away. 12 minus 13. I hope it's not too fast. Minus 1. Can? Then that's what's A is 1, B is 4 root 3, C is minus 1 plus 4 root 3. Not sure if it works. Maybe it could work. And then now we just need to solve for C in terms of solve for C using quadratic formula. So negative B plus minus square root of B square minus 4A C. And then you have a square root. Wow, very dangerous. Square root underneath and square root over. Square root of a square root is very difficult to simplify. All divided by 2 times 1. Okay? Simplify. Minus 4 root 3 divided by 2. I split it up as a fraction already. Plus minus divided by 2. Numerator, we try to simplify. 4 root 3 square. You can just use a calculator straight away for this. I get 48. Minus away 4 times negative 1 plus 4 root 3. Bring in the negative 4. 48. Positive 4. Negative times negative gives you negative 4, 4, 16 root 3. 48 plus 4, 52 minus 16 root 3. So square root of 52 minus 16 root 3. Eh? Then you're stuck. You know why?
Why?
Because this is not an exact value. You can't solve for an exact value.
Okay.
Actually, did the question ask for an exact value? They said without using a calculator. So they are basically indirectly asking you to solve it directly. How do you simplify this fellow? Square root of 52 minus 16 root 3. How to simplify? Doesn't it look familiar to a question we did before? Square root and then square root again. Let me show you. We already did one of the questions just now. Which one was it? I can find it first. Yeah, where did I? Is it question 18? I think it's question 8. Let me see. It's this one, question 25. Look familiar? Square root underneath a square root. But here, they are starting you off with square root underneath a square root. Sorry, square root 3 highlighted in the wrong order. Square root 3 underneath the outer square root. The A plus B is the unknown you're solving for it. Here, we are working backwards. They give you the A, they give you the B. Then you need to simplify it as probably something like C plus D root 3. Or maybe it's not even root 3 anymore. Could be some other value. So that we can solve the equation manually. So this question is quite challenging if you want to simplify this square root, which means that the quadratic formula method is not a very good technique to solve this question. Method 1 fails because of the question asking for without using a calculator. Unless you leave this as an answer. Okay, actually you could, but you need to clarify, is it plus or minus? The answer, it should be plus. It cannot be minus. Do you know why?
Why?
Why C cannot be minus? Where did C come from? Where did C come from? Read the question again.
The side.
The side length. If C is if C is the negative version, this guy, I believe that if you just manually key in a calculator, you will get a value that will you will get 2 root 3 plus c to become negative. So you have to reject the negative answer. Okay?
Okay.
So I reject. But I don't think that's what the answer key is looking for. They want an exact value. So this square root of a square root, you cannot leave as the answer. This is incomplete. Even though you rejected this and you accepted this, you still need to continue and simplify. So this is not so good. So what is the better method to solve this? Let's go back to the quadratic and see how we can solve this. The technique is to compare left and right side. Okay, we did this a few times already. Comparing sides. So do you notice there's a square root 3 here? Do you notice there's a square root 3 there?
Yeah.
What we're gonna do is we're gonna swap it around. So c squared plus 12 plus 4c root 3 equals to 13 minus 4 root 3. Can you see the pattern? I highlight it. Numbers on its own without square root. The number that's in front of the square root. Can you see a pattern?
Okay.
Now you see the pattern. You just need to compare blue with blue, yellow with yellow. So c squared plus 12 equals to 13. Then 4c equals to, I don't know, what is it? Negative 4. Then you can solve. Divide by 4, negative 1. Here, does it work? C squared, if you try to solve, you get 13 minus 12, which is 1. Then c you solve, you get plus minus 1. So over here, what we need to do is we need to satisfy both equations. This should be an AND, logical AND. So which is the one that is pickier? Negative 1 is the negative 1 is pickier. So therefore, c equals negative 1 is the only solution. Double box. Okay. A lot simpler, right? So your goal, so the difficulty is how in the world are you going to simplify this into a negative 1? You type in a calculator, you can get negative 1, but that's going against the requirements of the question. They requested for no calculator. So how in the world are you going to show it's negative 1? Don't need, don't bother. You can try it for fun if you want or not. Okay? Can. That's all. Then later I'll assign you your homework. Okay, that's all for today.
Okay.
Yeah, I'll send you a message. Okay, for the homework. All right. Let me stop the recording.